Now let's take a quick look at histograms, much loathed by GCSE students, but really not so hard as long as you remember they're all about areas. We're going to start with some data based on an experiment. We see how long it takes people to complete this particular task, and we find the times vary from 0 to 120 minutes. So we put the data in a histogram, and without paying any attention to the fact that the y-axis doesn't appear to have any numbers on it, we can immediately tell that the data's skewed to the right. We can also tell that most people seem to be completing this task in between 30 to 80 minutes. And for some reason, 30 to 40 minutes seems a very popular time for people to take. If I was the experimenter, I might want to ask the question why. But how did I actually draw that histogram? I'm going to take away 2 of the bars and redraw the table at the top. And the 2 extra columns I've got at the top, I'm going to label the bar width and the bar height. By the bar width, I simply mean this gap between 0 and 30. So for the first one, it's 30. 30 to 40, well, the width is obviously 10. 40 to 60, it's 20, and 20 and 40. The bar height can be calculated very simply when you remember that the frequency has to be equal to the area. What I do is I look at the area of this bar down here. It measures 30 wide. I know the area has to be 30, so that means it must be 1 high. Well, if that box goes 1 up the y-axis, I suppose I can mark 1 on the y-axis. And I guess if that's 1, then that really ought to be 2, and that should be 3, and that should be 4. Let's see if all of that works. The second bar here is 10 wide. It has to be 35 high. 10 times 3.5 is 35. Oh, look, the second bar is 3.5 high. 40 to 60 is 20. 20 times 3 is 60. And sure enough, this bar is indeed 3 units high. Now 60 to 80. 20 times what is 30? 1.5. So down here, I draw a bar that runs from 60 to 80 and goes up 1.5 units. And finally, the one that's 40 units wide and has an area of 20 needs to have a height of 0.5. I draw it down there. Now, obviously, these numbers here aren't frequencies because the areas are the frequencies. We call it the frequency density. It's just a technicality. The important thing is that you can draw them, and most important of all, that you can make sense of the actual data that is being shown to you.